Welcome to Across the Globe. Today we will learn about structs and methods. In Go, structs are used to create custom data types by combining various data fields. These data fields can be of different data types and are organized under a single structure. For example, if you are working on a program that involves storing employee information such as name, age, and salary, you could create a struct named employee with fields for name, string, age, int, and salary, float 64. Methods in Go refer to functions that are associated with a specific struct type. These functions can access and manipulate the data fields within the struct. Continuing with the employee struct example, you could define methods like calculate bonus or update salary that perform operations on the employee's salary based on certain criteria. By using structs and methods together in Go, you can create organized and efficient code for handling complex data structures and behaviors. A struct in Go is defined using the type keyword followed by the struct name and its fields within curly braces. Each field has a name and a type. For instance, a struct person with fields name of type string and age of type int is defined as follows: type person struct, name string, age int. To create an instance of this struct, you can use the following syntax: p person name Alice, age 25. In this example, a person instance named p is created with the name field set to Alice and the age field set to 25. This instance can be accessed and modified using dot notation such as p.name or p.age. This allows for organizing related data into a single unit, enhancing code readability and maintainability. In Go, methods are functions associated with a specific type. They enhance the functionality of the type they are defined on. To define a method for the person struct in Go, the method is declared with a receiver of the person type like this: func p-person say hello, fmt println hello my name is Pete name. Here, p is the receiver of type person, allowing the method to access and manipulate the fields of the person instance. To call the say hello method on a person instance, you use the instance's variable name followed by the method name and parentheses like this: Pete say hello. This line of code will invoke the say hello method on the person instance p, printing a greeting message that includes the person's name. The given Python code defines a class named rectangle with attributes length and width, along with a method area to calculate the area of the rectangle. An instance rect of the rectangle class is created with length 5 and width 3. The area of the rectangle is then calculated using the area method and printed. By following the provided code snippets, a rectangle class can be defined to represent rectangles in a program. Instances of this class can be created with specific dimensions, and the area of each rectangle can be easily calculated using the area method. This approach can be useful for various applications involving geometric shapes, such as in a program for calculating areas of different shapes to assist in architectural or engineering projects. A struct is like a toolbox that holds different tools, and each tool has a specific function. Methods are like the tools in the toolbox, each performing a different task. Just like how you can use a screwdriver from the toolbox to tighten a screw, in programming, you can use a method from a struct to perform a specific operation on data. For example, a struct called car can have methods like start engine or accelerate to perform different actions on the car data. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code snippet provided demonstrates the use of structs and methods in Go programming. In this scenario, a struct named car is defined to model properties of a car like brand, model, and engine. Two methods, start engine and accelerate, are associated with the car struct. The start engine method activates the car's engine by updating the engine field to running and displays a message indicating the start of the engine. The accelerate method simulates the acceleration of the car and displays a message stating the acceleration of the car based on the brand and model attributes. Within the main function, an instance of the car struct named mycar with the details of a Toyota Corolla is initialized. The start engine and accelerate methods are called on mycar, resulting in the engine starting and acceleration being simulated for the Toyota Corolla. The expected output from running this code snippet would be starting the Toyota Corolla's engine, accelerating the Toyota Corolla. Overall, this illustrative example showcases how structs can encapsulate data related to objects like cars, and methods can be utilized to perform actions specific to those objects, enhancing code organization and clarity. It portrays a real-world application where a car object is manipulated through methods to emulate starting the engine and accelerating, reflecting a fundamental concept of OOP in Go programming. One industrial example of using structs and methods is in developing a point-of-sale (POS) system for retail stores. In this scenario, a product struct can be defined with fields like ID, name, price, quantity, etc. Various methods can be defined for this struct to perform operations like adding items to the cart, calculating total bill amount, applying discounts, etc. Using structs and methods in this context helps in organizing the code effectively and encapsulating related functionalities within the struct methods. Another real-world application could be in a task management system. A task struct could be defined with fields like ID, description, deadline, status, etc. Methods can be implemented to mark a task as complete, set deadlines, prioritize tasks, and so on. By utilizing structs and methods for tasks, the codebase becomes more maintainable, modular, and easier to extend with additional functionalities. In conclusion, structs and methods in programming provide a powerful way to encapsulate data and behavior within a structured format, enabling better organization and management of complex systems or applications. Keep learning, stay curious, and I'll catch you in the next video.